Hi there, welcome to the world of chemistry. In this video, we will talk about the differences between the two structures of solids, crystalline and amorphous solids. But before that, we know that solid has definite shape and volume, and its particles are tightly packed together. Crystalline solids consist of atoms, ions, and molecules arranged in definite and repeating three-dimensional patterns in a highly ordered microscopic structure. There are four types of crystalline solids: Ionic Crystalline Solid, Metallic Solid, Molecular Solids, and Covalent-Network Solids or Atomic Solids. Ionic crystalline solids are made up of oppositely charged ions held together by electrostatic attraction. It is a solid that consists of cations and anions held together by electrical attractions of opposite charges or ionic bond. They are hard and brittle. They have high melting points because the ionic bonds require a lot of energy to break. In solid form, ionic compounds are poor conductors. Metallic solids are metal atoms held together by the metallic bonds. Metals are not covalently bonded, but the attractions between the atoms are too strong. In metals, valence electrons are delocalized throughout the solid. Molecular solids are made of molecules or atoms held together by intermolecular forces, not covalent bonds. They tend to have low melting point. The IMF or the intermolecular forces are weaker than ionic or covalent bonds, so molecular solids are relatively soft and flexible. Polar molecular solids like sugar will be soluble in water. Covalent solids are held together by covalent bonds in a large network. They are different from molecular solids because atoms or molecules are covalently bonded to each other, not held together by molecular forces. Covalent solids tend to be hard and brittle. Graphite is no notable exception because its covalent network takes the form of two-dimensional sheet of graphene, just one thick atom. Amorphous solids, a non-crystalline solid in which the atoms and molecules are not organized in a definite lattice pattern. The crystalline solids have long-order arrangements of the particles. The amorphous solids have short-order arrangement of particles. Crystalline solids are anisotropic to nature, that the physical properties are different in different directions, while the amorphous solids are isotropic in nature, that their physical properties are same in all the directions. Crystalline solids have sharp melting point. It means that the range of melting point is very small, that it melts over very small temperature. The amorphous solid melt over a certain range of temperature. Crystalline solids are rigid, and its shapes are not distorted by mild distorting forces. Amorphous solid is not rigid, that they can be bending or applying compressing forces. Crystalline solids have definite characteristics and shapes, while the amorphous solids have an irregular shape. Crystalline solids are true solids, while the amorphous solids are pseudo-solids or supercooled solid liquids. Crystalline solids have definite and regular arrangement of constituent particles in spaces. The amorphous solids do not have any regular arrangement of constituent particles in a space. When you cut a crystalline solid, it undergo a clean cleavage. On the other hand, amorphous solids undergo an irregular cleavage when cut. The examples of crystalline solids are ice, table salt, and diamonds. The examples of amorphous solids are glass, cotton candy, and rubber. So that is the differences between crystalline and amorphous solids.